Okay, hi everyone again. This time I'm using my headphones, the mic of my headphones. Let's see if the quality is a little bit better than before. Okay, yeah. What are we going to do today? Or I thought maybe it would be nice if we do a little bit more on classes and objects. So we could um, search for some definitions. What what does documentations say, say the or how do other documentations explain what are classes and objects in Java? So let's see what we get first here. This W3 schools. Yeah, let's check out this definition first. Java. Java classes and objects. Everything in Java is associated with classes and objects, along with its attributes and methods. For example, in real life, a car is an object. The car has attributes such as weight, color, and methods such as drive and brake. A class is like an object constructor or a blueprint for creating objects. Did I say object? A class. A class is like an object constructor, a blueprint for creating objects. Yeah, I think that's nearly the same definition we talked the last lesson, but let's dive a little bit more into it. So let's see. Um, everything in Java is associated with classes and objects, along with its attributes and methods. So last time we also learned that a class has attributes. Last time I think we called them fields or members. So the naming is this. I don't know what's 100% if there is a one name which you should use in Java, but there are many names for attributes like properties, fields, members, attributes. So for this session, let's call them attributes. But in the last session, I think we called them fields, just that you know that those things refer to the same. So let's take the example. For example, in real life, a car is an object. The car has attributes such as weight and color, and methods such as drive and brake. This also fits the definition from last time. We said last time I think we had the farmer, and we said the farmer has attributes like his name and the number of logs I think he has. And methods, for example, were something like I think last time was the farmer could chop a tree. Yeah, he could chop a tree. Yeah, and get wooden logs out of the tree. So this time here it's a car, and there also the methods are something that the object is doing. So the object, the car drives and the car brakes. So not to brake, but to brake to stop, not not to going to destroy the car. We're going to stop the car. So let's implement it in Java maybe. Let's see. So nice. Good. So in real life, a car is an object. The car has attributes. So let's create a car. Um, I don't know. We've got a Skoda, and how do we use objects? Yeah, it's a little bit a repetition from the previous session, but I think to just to cover a little bit more or try to get a little bit more understanding. So in this example also, a car is an object. How do we represent an object? We are creating classes, and this we try to represent this car in Java with the use of classes and their attributes, the attributes of the car like weight and color. Okay, I think that's too fast. Let's step back a little bit. So third thing, how do we represent a real life object in Java? We use classes. Classes are, yeah, for for representing objects, and you stuff them with, or you use attributes and methods to tell what this object can do and does for you and also for other programmers. So in this example, yeah, like I said 100 times, we got a car. So let's create a class called car. So now we have an empty class, car. Now we want to describe this class a little bit more. So the car has attributes such as weight and color. Yeah, attributes. Like in the last time, we called them fields. So uh, let's append. Let's append some attributes to this class. Um, weight. Weight is probably let's 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 lose let's use float for this purpose. Private float weight private color. Let's use a string for simplification. String color. So now our our car got those two attributes, and we can again again we try to hide the implementation of the car and to the outside world. The outside world in this example here is outside of the class. We just for the outside world or for outside of the class, we want to make only things available which we really do, which we really need to. Like, let's say we wanna set the weight and the color of the car, so we can generate or use getters and setters. The shortcut in IntelliJ is Alt and insert. Alt insert. Then you get this generate context menu, and there you can generate your getters and setters. Which this does is it just automatically generates the getters and setters for you, so we can retrieve the value of weight, and we also can set the value of weight. and we can retrieve the value of the color, and we can also set the value of the color. Now, outside of the class, we have get color, get weight, set color, set weight. Those were those four methods. We can see them because they have this access modifier, public. This access modifier makes them available outside of the class, like in the main, for example, or wherever you create an object of this class. Yeah, those two, weight and color, we cannot use them outside. That's perfect, that's fine. We also don't want to use them outside. We don't want to use access fields directly. We want to hide them and just represent the want to hide the implementation and just represent methods which are really only those methods which are needed from the outset. So we can set the weight now let's say in kilograms. Let's say our Skoda our Skoda's weight is 1,200 kilogram. The color, we can set the color. Maybe Skoda is a bad name for a car. Let's say it's the Skoda Felicia. The Skoda is the brand of the car, it's not a car. But yeah. Color. Our Skoda is white, of course. So now we used this construct car Skoda equals new car to create an object. Skoda in this case is an object of the type car. Car is the class, and Skoda is an object. And the class is the blueprint for an object, like how it looks, or which attributes it has, how it looks, which attributes it has. Those are two things, and what it does, which method it has. It's a rough explanation, but yeah. Let's print. Last time I saw, I think there's a printf. Yeah, printf. Wait. I don't know what's Java printf float. What's placeholder for float? Percentage %d. For numbers, for f, it's f, percentage f, value of the integer. Yeah, let's use f, weight, and we got also the color percent s, I think, for string. So Skoda dot get weight and Skoda dot get color. Okay. Control Shift F10. It's a shortcut to run. The main file, yeah. So now, yeah, okay. We got 1,200 kilograms, and I think we can also specify the number of digits behind the Point two, something like that. No. Float, nee, Java, printf, float, 2 decimal. Point two, just point two percentage, point two, point two f. Yeah, of course. Okay, let's abort this and run again. So, yeah. Nice. So if you stuck or don't know anything, or you need some answers, just use Google or any other search engine. Google is your friend in this case. In this case, Google is a friend. Okay, good. So let's let's get back to the definition again. What did we cover? Everything in Java is associated with classes and objects, along with its attributes and methods. Yeah, we got attributes like weight and color, and we also got methods. In this case, we got getters and setters. Those are also methods to get color, to set color. But we can also attribute this real life example, such as weight and color, and message, such as drive and break. Let's say we got a method drive, and drive just sets the current speed. This dot set current speed equals to 100. This just sets if we say we have two buttons in our car, drive and brake. Drive and brake, if we hit drive, we got 100 kilometers per hour. And if we hit brake, the brake button, the current speed equals 0. We just brake. We stop the car, not we brake the car. Oh, brake is we can't use brake for this example. Brake is a keyword in Java. It's already reserved for for a switch statement. You got some input here, current speed. Yeah, this doesn't exist, but and there you have these cases. Case if the speed is 0. How do I write this in Java? Case 0. We do set the color. I don't know. We do something, and then we make a break to break to to say, okay, if you're in this case, we will do this. We will call this method, and then we will stop. We will break and won't continue the other cases. We will just break, and after the break, we are here. The execution of the program is here and continues after the curly bracket, curly brace, bracket, curly bracket, bracket, brace, bracket. Okay, bracket. Let's call it curly bracket. 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 Curly bracket. Parentheses. Curly parentheses. That's, I think we should use this word, parentheses. The internet is so slow again. Okay, parentheses. Parentheses. Okay, we use curly parentheses. We use curly parentheses. No, we don't use curly. Yeah, we use curly parentheses a lot. But after the execution, if we hit this break, the execution continues after this curly parentheses of this switch statement. So because of this, we can't use break. Let's call it stop. Okay, we need the current speed. We create a field, attribute, property, member, field, current speed. Okay, nice. So we also again can use Alt and Insert to generate getter and setter for our speed. Current speed, we don't use the setter. We set the speed with drive and stop anyways. And let's get this to order. And just use the getter to retrieve the current speed. So Skoda.drive south speed, or current speed is what's speed is integer percentage d, I think. Current speed percentage d Skoda dot get speed, and now we stop the car, and it should be down to 0 again. So let's first current speed percentage d Skoda dot get current speed. Okay, Control Shift F10. Yeah, Control Shift F10. Let's see. Now, yeah, of course, we don't have an not south. South. We got no brakes, line brakes. I think we can also use something like that, but yeah, use those brakes. What? Control Shift F10. Okay, good. Now we got our class car. We are creating the object Skoda. We use a method, a setter in this case. Set is also a method. Method set weight to set the weight. We use the method set color to set the color. Yeah, we print the thing. In the beginning, the speed is 0. Then we press the button drive, and we are speeding through the highway with 100 kilometers per hour, and then we hit stop, and the car stops. It's down to 0 again. Okay, good. So let's take a look at the definition again. Everything in Java is associated with classes and objects along with its attributes, weight, color, current speed is an attribute. Weight, color, current speed is an attribute V added to simulate drive and stop. And methods such as drive and stop. In this case, brake we can't use. Brake! Okay, I'm sorry. I'm sorry. Yeah, we can use brake, of course. I just, yeah, misspelled it, of course. Okay, let's refactor it and use not brake, but Shift F6. Shift F6, brake. Use brake to hit the brakes and stop the car. Brake. I broke the car, but I just wanted to stop the car. Okay, I'm sorry. Good. Yeah, we're learning English and, and Java together. Okay, good. Yeah. In real life, a car is an object. The car has attributes, weight, color, methods, drive, and brake. And again, just one time, we don't expose the we hide the implementation. We don't expose the implementation. We don't expose those fields directly, like current speed. The user shouldn't care about if there's a current speed or whatever speed in this class. He just wants to drive. He has two buttons. He just wants to drive and brake. That's it. And in our case, we also want to set the color and the weight in the beginning. We can also, for example, set the weight and the color in the constructor at the beginning. So let's, or yeah, maybe we should first learn what's a constructor is, but step back. We hide the implementation of the class. We use methods to expose only things the user really needs in the end. The user is, in this case, someone who uses this class. You or another programmer, a colleague who uses this class. So he instantly knows, okay, this drive, this car, Shift F6, Skoda Felicia. So our Skoda Felicia has two methods, drive and brake, and getters and setters. Good. Yeah, that was this definition. Yeah. Of course, we also can use the constructor to initialize those things, for example, weight and color. Let's say car, we don't want to write set weight and set color each time. We use the constructor for the initialization. And yeah, let's get rid of those setters. Use the constructor. Yeah, a constructor, like the name already says, is something which is used to construct an object. So let's recap. This is our object we want to construct, and this is the class, the blueprint. So we say in this line, this Skoda Felicia is a new car, and the constructor, and we pass two arguments to this constructor. And please, constructor, take those arguments and give back a car in the way we expected. So we got our float weight and our string color. And in this constructor, we just want to say, weight, of course, distance weight equals the weight we passed as an argument. Distance color equals color the argument we passed. So what did we do? Now we created a constructor with two arguments, weight and color. And now we are not using the setters outside to set the color and the height. We pass it through the constructor. And inside the class, we don't have to use these setters because we have access to our private attributes, fields, members, properties to alter them or alter their value. Set a value, get a value, do whatever you want. Okay, so for example, if you also don't want to use that weight get weight anymore and want to enforce, hey, everyone who uses this class has to use this constructor, just get rid of the setters, and if you prefer constructors instead, now you only can use constructor to set those values. So now you only can retrieve values and set the current speed through those two methods. But again, the user doesn't care what you're doing. He cares in a way what you're doing in this method, but he expects that, I don't know, something is happening if you use drive and brake and shouldn't care about the implementation. Good. I think we covered this example. The beginning was a little bit confusing. I was also a little bit confused. I didn't take any notes how to do it, just a little bit freestyle. Let's take another definition maybe. Java classes and objects. Let's try to not do it that confusing. Oh, docsoracle.com. Yeah, that must be nice definition. Let's see what they say to classes and objects. Okay. Okay, with the knowledge you now have, you learn how to write your own classes. In this lesson, you will find information about blah, blah, blah. You'll learn to use classes. You will learn to use classes to create objects. We have this statement here. We use classes, the car, to create an object. This object is Skoda Felicia for this example. Oops. And how to use the objects you created. How to use the objects? We use the objects with the, I think it's called dot notation because you write the object name and use a dot to use the object, to use methods, fields, whatever from the object. You use the dot notation to interact and use the object. Okay. This lesson also covers nesting classes within other classes and enumerations. We won't nest classes and also not enumerations. Classes. This section shows you the anatomy of a class and how to declare fields. Fields. Here we have fields. In IntelliJ we also have fields. What was attributes? In Sololern they are called attributes. And in this previous W3 school, we also have attributes. So 2 times fields, 2 times attributes. Nice. Methods and constructors. Let's do this. Okay, classes. The introduction to object-oriented concepts in the lesson titled Object-Oriented Programming Concepts used a bicycle class as an example, with racing bikes, mountain bikes, tandem bikes as subclasses. That's inheritance. We won't address inheritance in this session. Maybe I think solo learn in assignment 2 and in assignment 3 and 4, I think we will use inheritance. Here is sample code for a possible implementation of a bicycle class to give you an overview of the class declaration. Subsequent sections of this lesson will back up and explain the class declaration step by step. For the moment, don't concern yourself with details. Okay, so there's no definition. They use they use code to define what are classes and how to use them. Maybe there is a definition somewhere. Oh, for sure, there's somewhere. Hello? Oh, okay. Technical issues. Good. I think you should hear me again. I hope so. Ah, nice. We found a definition. Um, okay, if you never used object-oriented programming language before, you will need a blah blah blah. This lesson will introduce you. What is an object? An object is a software bundle of related state and behavior. Software objects are often used to model the real-world objects that you find in everyday life. Those sentence, we also applied those sentence here. So we got a car and we tried to model the car, a real life object, in code, in Java code. The car got weight and color and the current speed, and those are the attributes. We use a constructor to initialize, to create an object, to initialize the attributes or whatever to initialize here. And we use methods, in this case to getters to retrieve values and also to methods to alter the value of the current speed. Yeah, good. This lesson explains how state and behavior are represented within an object, introduces the concept of data encapsulation, and explains benefits of defining your software in this manner. Okay, what is a class? A class is a blueprint or prototype from which objects are created. We also applied this here. A class is a blueprint or prototype from which objects are created. we got an object, Skoda Felicia here, and the blueprint or prototype here. And, and here we create the object, or we say, please, car, give me an object. Here are those two arguments, the weight and the color. Please create an object for me and sometimes I'm missing many vocabularies in English, I'm sorry. Um, please create me an object with those two arguments, weight and color, and initialize or give me back this object, and I will, what does zuweisen mean? Zuweisen. Allocate, refer, assign, assign, assign. Assign is good. Some words I'm using all day long, I can't remember them anymore in some time. Yeah, whatever. And assign those objects you created for me to Skoda Felicia. Good. This section defines a class that models the state and behavior of a real-world object. It's the state and behavior. It intentionally focuses on the basics, showing how even a simple class can cleanly model state and behavior. Okay, let's dig a little bit further into this. Okay. Objects are key understanding of general. They have a state and a behavior. Dogs have a state, name, color, breed, hungry, and a behavior. Barking, fetching, wagging tail. So they refer the state to our attributes, fields, members, properties. So in our case, the state of our car is the weight, the color, and the current speed. And the behavior of our car are those getters. But most important, a car drives, a car brakes, not brakes. So let's get back to this main definition. So that models the state and the behavior of real world objects. So we model the state and the behavior of the real world object car. Good. Yeah. Okay. What else can we say about classes and objects? Let's search for another definition. Oh, Bildung. I don't know how to pronounce it right, but let's say Bildung is also a really nice page to learn about really many things. Okay, here they say many IT related things or Java related for. It's only Java? I don't think it's only Java. They also got some other things, but Bildung is really as mostly Java. It's only Java. And also some concepts. Okay, it's not only Java, but concepts you apply with Java, maybe, and Java. Get started with Java. So this is also really nice. I used it a lot with in one lecture. In one lecture, we used this a lot to introduction to distributed oriented programming. I think this distributed services. I don't know, whatever. Okay, I'm sorry. But it's nice. It's also really nice. The Oracle documentation is also really nice. The W3C documentation, I don't use this a lot for Java, but why not? But Oracle and Bildung are both really nice. Got nice examples and nice explanations. Okay, in this quick tutorial, we'll look at two basic building blocks of the Java programming language, classes and objects. There are basic concepts of OOP, which we use to model real-life entities. In OOP, classes are blueprints for templates or templates for objects. Yeah, I think I don't have to repeat this. We use them to describe types of entities. Yeah, so here they don't use the word object, real life entities. They say real life entities. They mean with entities, they mean car, tree, farmer. On the other hand, objects are living entities created from classes. So objects are created from classes. They contain certain states. They contain certain states with their fields, three times fields and two times attributes. So fields is the winner and present certain behaviors with their methods. They present behavior with their methods. Drive, brake, get color, get weight, get current speed, brake. simply put, a simply put, a class represents a definition or type of object. Yeah, a class is a type of an object. So you also say the Skoda Felicia is of type car or has the type car. Then you can also sort. I don't know how it's in Java, but that's in C# there's a type of Java get type of object. How do you do it? This in Java dot class dot get class get class. Yeah. So this prints the class car, the package name. We are in package RT or the path to the class. So RT module 3 car. Yo. Okay. In Java, classes can contain fields, constructors, and methods. Yeah, we also have this here. We have our fields, our constructor, and our methods. And here again, we have our car, fields, constructor, methods. Yeah, it does have one type. Oh. Yeah, okay. This Java class represents a car in general. We can create any type of car from this class. We use fields to hold the state. Fields hold the state. And constructors to create objects from this class. Yeah, so like here, we pass through arguments and get a car back, which we assign to Skoda Felicia. Every Java class has an empty constructor by default. That's true. So if you don't specify, also if you don't specify a constructor, and behind your class, you can every time you can automatically make this call, and it's correct. The compiler knows what to do. Just give me a car back, and in this case we don't specify an empty constructor, default constructor without arguments, and in this case all fields after the initialization got a default value. I think for float is 0.0, f string is null, int is 0. So all those fields will have the default value. But of course, we can also specify the default constructor in the code, and we can override the behavior. So here we can initialize weight and color by default. So if you just use a default constructor now, we set those values every time, and yeah, you don't have the option to override those values, for example, now. To override them, we also can make use of setters again, but yeah, first we of course have to generate a setter, and now we can use setters again to override the initialization afterwards, or the initialized value afterwards. Good. Create a mess right now. Okay. Okay. Genau. Every Java class has an empty constructor by default. We use it if we don't provide any specific implementation, as we did above. Here's also a constructor with 3 arguments, and here is an empty constructor. Here's how the default constructor would look like in our class. Okay. This constructor simply initializes all fields of the attribute with the default value. So like I said before, strings are initialized to null and integers to 0. Whoa. Okay, it's creepy now. Now, our class has a specific constructor because we want our objects to have their fields defined when we create them. Yeah, like we also did. We got rid of the set weight and set color and used the constructor with 2 arguments instead. Okay, objects. While classes are translated during compile time, objects are created from classes at runtime. Yeah, so those things are, the compiler also already knows those things during compile time. So if you compile, if you hit Control Shift F10 and we are compiling it, Control Shift F10, maybe because nothing changed. I don't know. Maybe because we're not inside this. Yeah. Now we're compiling it, and the compiler knows how the car looks like because we specified it here in the code. And those objects got, how's the wording? Objects are created from class, yeah. And if we start this, how can I make a breakpoint? Break here, breakpoint, breakpoint, breakpoint. Whoa, how did I do this? Oh, here. Okay. Okay, now I have to figure out how to Debug is no shortcut available. Okay. If we run this project, first first time debugging is IntelliJ. Okay, if you run this project, um, is this okay? Okay, yeah, yeah, gets created at runtime. So now the object doesn't exist right now because we stopped at this breakpoint. So we didn't run this line. We didn't run this line. We stopped at this line. So now the execution is on the line above. Roughly said now in this example. Um, so this Coda Felicia object doesn't exist right now. If we F8 do one step, now we are in the next line and we have a Skoda Felicia here. Now the object got created during runtime because we're running the project. We're debugging it and we got our properties. We got weight, we got color, current speed, and if we go further, F8, oh, yeah, F8, F8 drive, we can inspect it here. Current speed is 0 because we are stopped at this line, so we didn't execute this line. Now we will execute this line. Now our speed is 100 because we in drive we set the speed to 100. Now we break, speed is 0. F8 is to step over and F7 is to step into. Can I go back in time here? Can I go back in time, run to cursor, run to cursor? No. Yeah, just mention this maybe. F8 is to step over. So we roughly said we are using now we are in this file and we don't want to jump out of this file, so we just want to inspect the execution, what's going on in this file here, code file. So we can jump over a line, jump over, and if we wanna jump into those method break, for example, we can use step into step. Sorry. Step over, step into. We can use F7 or step into to step into this method. Now we are in break. Here the same thing. We can use step into, step over. Now we're back and let's just resume it. F9 is resume. Okay. Yeah. So objects are created from classes at runtime. Objects of a class are called instances. Yeah, another word for calling this is you can say golf is an instance of car or an object of car. It's the same like you say fields or attributes. I'm not sure if those fields and attribute wording are really the same or they've got small differences, but we'll find it out during these 4 assignments. Okay, yeah. Now we've created different car objects from a single class. Yeah, of course, you also can you can create more objects of the same class. So Skoda Fabia, we also got a Skoda Fabia. What are Indian car brands? Brands. Tata Motors, Tata Motors model. Okay, Tata cars. We got, oh God, this is slow. Harrier and our Nexon. So we got our Harrier. Tata? I hope it's right. Car Tata Nexon. Nexon. They look like you can drive everywhere. They look like little tanks. Cars. Okay, we got a new Tatar, our Tatar Nexon. Oh, that for sure weighs much more than, oh, that weighs much more than one, let's say 500 kilograms. Color, sorry. And this thing just IntelliJ shows you those, not prefixes, but those hints that you can, that you automatically see which argument this is. This argument is for the weight, this argument is for color. So normally there's nothing, and only IntelliJ adds this for readability purposes. Good, now we have two cars, a Harrier and a Nexon, and we can independently call drive and brake, and if you can, we can execute it once, and like you see, we can independently alter values, alter the state attributes fields of the cars. So we got our Harrier. Now I also, okay, now we have our Nexon and our Harrier. Our Harrier is white, our Nexon is red, our Nexon is on a highway with 100 kilometers per hour, and the Harrier is still at 0 in the parking lot. Now Harrier is also on the highway, and yeah, so you see you can create more objects of a class and also independently alter values, use methods, and so on. Okay, cool. Yeah, now we have changed the state of our class. There are different speeds. It's crazy. I haven't looked at this tutorial before, I swear. I really have to practice my pronunciation a little bit more. Okay, access modifiers. In the previous examples, we omitted access modifiers to simplify the code. By doing so, we actually use default package private modifier. That modifier allows access to class from any other class in the same package. Usually, we would use a public modifier for constructors, modifiers. The idea, the overall idea, but we also talked about this earlier. For access modifiers modifiers are those things, public, private. There's also model, string model. You can also specify none, no modifier, and protected, I think, yeah, protected brand, and protected string brand, and protected. I think default is protected. Java default access modifier. Okay, so we have our private float color current speed. Like I said before, theta Harrier or our objects, we won't see those three attributes, but we see brand and model. Brand has at the default modifier, if you don't specify anything, the default modifier gets used. It's the same thing like the constructor. If you don't specify a default constructor, it if you don't implement a default constructor, it's there, but you can use it anyway. You can use it anyway. New car is you can use anyway the default constructor. Also, if you don't implement it, it's there. It's like the default access modifier. You don't specify a default access modifier, but it's there. When we don't use any explicit Java, we set default method, default access method, also called package private. It means that all members are visible within the same package, but aren't accessible from other packages. So this means if our class is in the package RIT module 3, and our main is also in RIT module 3, we can access those two fields, those two fields. But, okay, again back. Private, only this class. Private means this attribute is only available inside this class. Protected means that this attribute is only available inside this package. And public means that this method or this field is available also outside of packages, outside of the class. So if, for example, our main is in module 4, can we do this? Just have to import car or import car. Yeah. Now those two things, model and brand, are gone. They vanished. They're not accessible anymore because of this access modifier. We specify protected and default. Default is also protected. Good. Yeah, I think let's finish here. I hope that makes some questions clear, or is a little bit more insight into objects, what objects and classes are really are in Java. So, and yeah, let's try it with a little bit more structure next time. Thank you and see you soon. Ciao.